in today's session, we are going to look at finance. Finance can be very tricky. Why? Because we don't have money. When we have money and we have lots of it, it can make much more sense. And I met many students saying we need assistance with finance. And in today's session, we are going to go through a few finance calculation. And as you can see, the information that's on the board, it's a previous question, last year 2023 final examination question, whereby Patrick invested 18,500, and after 6 months it had accumulated to 19.319.48, 19,319 rand and 48 cents. And we were told that the conversion is compounded every month. So in a year, we can see that it will be 12 times. And like I said, this value was achieved in half a year or 6 months. Now, I know that in our formula sheet, this is the formula that's given. This is the formula that's given. We are given this, but of course, we can change that based on how many times the conversion occur or it's compounded. This is a formula for compound once a year, but when it's compounded monthly, we get this formula, which is the number of conversion, and here on top we just multiply again by this number of conversion. So as you can see there, we have the whole information about this problem. We are asked to calculate R, and like you see on this formula, the accumulated value, which is 19,319.48, is equals to P, which is 18,500 into 1 plus R into 12. The R has to be over 100 as well. 12 times 100 into what is the N, the time, in years, it's 0.5. This is expressed as N in your question or in your formula. This is 0.5, 0.5, because it's 6 months. After 6 months, we achieve this value. So it's 0.5 year or half a year. Then you multiply by this M, which is 12, the number which conversion take place. And eventually you get this 19,319.48 is equals to 18,500 into 1 plus R over 1,200 to the power 6. Now, what we are left is to calculate this value of R, and we'll have to do this. I will just shorten it by pressing my calculator, and we have 19,319.48 divided by 18,500, which is 1.0443 is equals to 1 plus R over 1,200 all to the power 6. Now, what we can also do is to take the sixth root both sides. Then you're going to have 1.0443 is equals to 1 plus r over 1200. Now you can calculate this 1.0443 to the power to the power to the power 6, you get 1.00725. Let's check if that's correct. 1.00725, which is equals to 1 plus r to the power 1200. Now the job is done for us. You can just take this side, you are going to remain with 0.00725, and if you multiply by 1200, you are going to get r value, which is equals to 8.7. Now, I'm sure it might be confusing for everyone, but I took the one this side, 1.00725 minus 1, then you are left with this value. You multiply by 1200 and you get the value of 8.7. And this is our final answer for R. And we are going to tackle the next question. One of the students asked me, why do we have to convert to 6 months? Why can't it just be a year? And later on, I will show you exactly what is the important, or how does the conversion, whether it's monthly or 6 monthly or yearly, impact your return. The most important value is your accumulated value. But the more frequent the conversion take place, if it's done monthly, this value is higher than when it's done yearly or quarterly. And when it's done daily, this value is also slightly higher than when it's done only monthly. So the frequent the conversion take place, the higher is your accumulated value. And I hope that I will do an example as we go on that really proves what I'm saying. So this is a question. If you really do this, you would get 4 marks in your exam. But the most important thing is to remember these two things. The conversion multiple, which if it's monthly, it's going to be 12. If it's daily, it's going to be 365. If it's weekly, it's going to be 4 times 12. You can, which is around 48. So the most important thing is to remember this. Of course, in your formula, it's given like this, but remember, you can multiply the n by the multiple times which the compound interest is accumulated. If it's monthly, the M is 12. If it's yearly, the M is 1. If it's weekly, it's 48. If it's daily, the value of M is 365. Yes, this is your figure of R. We'll go to the next question. I hope that you can think about what I've just said and practice and look at other problems using the same um, setup and see if it makes sense to you. Thank you very much. We'll go to the next question. Thank you very much. The second question, we are asked to calculate the effective interest. R effective, and we are going to use this formula that you see. R effective, we can also express it I over 100, which is equals to 1 plus R over N into N minus 1. Now we are told that the N now for the effective, it's for the whole year. For effective, we consider N for the whole year, which is the same as M. We are calculating for the whole year, which is, in this case, is going to be 12. Therefore, you've got I over 100, or percentage, we can say percentage. Okay, let's put it as I over 100 is equals to 1 plus R over N, which is 12. Remember, it's also multiplied by 100 because it's a percentage. And you have N, which is 12. Then you subtract A1. If you press your calculator here, we are going to have a figure of this. We had calculated, I think we said it was 8.7. Now let's look at what the calculator gives us. 1 plus 8.7 then to the power 12, then minus 1 equals to 0.0905. This is the value that you are getting. Now we have to multiply by 100 to get I. And then you're going to get your I value being, you can move 9.055%. And yes, remember this formula as well. I don't think it's given in your exam, but just remember this formula. Also remember, when you are calculating the effective interest rate, you use the entire term, meaning for a year, meaning when it compounds monthly, you use 12. That's why I use 12 here. That's why I also use 12 here. And then you get the interest rate of effective interest rate of 9.055. I hope you get this right. This is in 3 marks in your exam. Just to substitute using that formula and get it right in your exam. Thank you very much. We'll continue with more examples as we carry on. Thank you. Thank you very much. We are going to look at the next question, which tells us about Kuda, who buys a very expensive laptop for 10,000 rand, and he will only be able to replace it after 5 years. And we are told that the rate in which the laptop depreciates or loses value is 20%. And we are asked to calculate the value of n at which the value, the accumulated value will be 0. At what year will the laptop lose value completely? How is this important? It's very important when it comes to replacing things, knowing exactly when your equipment loses its complete value, so that by the time it loses value, you will have the budget to purchase a new one. Otherwise, if you don't know, it might lose value and stop working, and you wouldn't have the money so that you can replace that equipment. And if you can't replace the equipment, you might be left wanting. So this is the formula. This is a very straightforward calculation. You have A, which in this case will be 0. You've got the principal value, which is 10,000, and you've got 1 minus I, which is 20%, multiply by n. And this is your equation. Let's look how then this will affect everything. Let's look at how quick we can do this. Actually, this is very simple because we can just divide both sides by 10,000 and you still get 0 is equals to 1 minus 20 divided by 100. That's 0, 2 n. Now, if you look at this, you might as well take the one that side and you remain with minus 1 is equals to minus 0.2 n, and when you solve for n, you'll get n is equals to 5. So after 5 years, the value of this laptop will be 0 at the interest, at the decreasing or depreciation rate of 20%. Therefore, Kuda won't be in trouble because anyway his plan is to replace after 5 years. But imagine if his thought is, I will replace after 6 years at this value, then after 5 years, when the accumulated value becomes 0, the laptop might not continue working because the value has depreciated already, and he might find himself a year without laptop. So when we are projecting using the depreciation values, we need to be spot on with our calculation. We can use the previous experience to be able to estimate the year of which the equipment is able to last. This, of course, is a very simple substitution, and in the exam is 2 marks, and you can enjoy these 2 marks. We are going to the next question very shortly. Thank you very much. Thank you very much. The next question that we have is, Kuda want to now buy a laptop that is worth 20,000 rand, and he need to deposit monthly installment in a bank that will give him 8.7% interest rate per annum. then is compounded monthly, which means the value of M is 12. And after 16 months, how much does he needs to deposit so that he can accumulate this value of 20,000 rand, so that after 60 months he'll be able to buy his expensive laptop that is worth 20,000 rand. I really wish I could afford a laptop of this value. This is an extremely expensive laptop, but let's do the calculation. Let's see and solve the value of X, which is the value that he must continuously deposit into his bank account and receive the interest rate of 8.7% per annum over this period of 60 months, and with a monthly compound, so that he can reach this value. Like I said, this is the formula. Of course, in your formula sheet, it's not like that. But remember, the M needs to be used, which is very important. The conversion in which the compound is done. So you have the value of F, which is 20,000 rand, which equals to X into 1 plus interest rate is 8.7 over M. I said it's 12 months multiplied by 100. The 100 is for the 8.7. 8.7% is 8.7 over 100. Then you've got this to the power n. The value of n, since it's compounded monthly, the n is directly 60. But also, it can be, this n is also equals to m times t, which is the time in years. So if you take the 60 months and divide by 12, you are going to get 5. And then you can also get 12 times 5, which is 60, because we are given 60 months. To the power 60 minus 1 all over 8.7 over 112 times 100. This really looks very complicated, but let's see what we can do. We can say 8.7 divided by 1,200 multiplied by 20,000. We can have 145 is equals to X into, let's look at this value here. 1 plus 8.7 over 1,200 equals to the power 60 minus 1 0 comma 5 4 3 rounded to the nearest. Then for me to get X, I have to say X is equals to 145 over 145 divided by 0.543. This is 260 7.03. This is the money that Buddha will have to deposit on monthly basis so that after 60 months he can have the value in which he wants to buy a laptop, which is 20 grand. If he deposit 2,677.03 cents, he will definitely achieve his target of 20,000 rand after 60 months, when it's compounded monthly at 8.7 interest rate per annum. So thank you very much. I hope you can use this as an example in your exam and get full 5 marks in your exam for this. This looks very easy. The only trick is knowing how to use this, and knowing this, the most important thing is that and the value of m is equals to m multiplied by t, but the t must be in years. But if you're given in months, the n is given in months, and you are told that it accumulated monthly, you can just use the number of months as well. So this is the value of the amount that he will need to deposit into his bank account on monthly basis. Of course, there could be rounding off issues, but this is much fair value. Thank you very much. Enjoy this example. Practice while you are doing it. Look at um, more examples in this book that you have over here. Let's look at it. Look at the example in this book, and also in this book for grade 11, so that you can refresh your mind a bit. But this is the value that you get 5 marks. But remember all the steps. Remember the M, remember the T, remember the N, how do they relate, and good luck to all of you. Thank you very much. Let's quickly rush to the next question. Thank you. Thank you very much. In this question, we are told that Tino wins a jackpot of 1.6 million. Take the whole amount, invest it into an account which gives him 11.2% interest, and we are told that it's compounded monthly. We are asked to calculate this value of n, which is the number in which he can keeps on withdrawing. We are told that the value of x, which is what he's going to withdraw every month, is 20,000 rand. I really wish I was Tino, withdrawing 20,000 every month from a jackpot that I got 1.6 million, and the interest rates of 11.2. Now let's look at how many withdrawals can Tino make. Now we are given the value of P, which is 1.6 million, and then we are told that he's going to withdraw 20,000 a month, and we have 1 minus into 1 plus interest, which is 11.2. Now, like I said, we have to multiply the m, which is 12, because we are told it's compounded monthly. So in a year there are 12 months, so you put your 12, but because this interest is 11.2, we have to divide by 100 since it's a percentage, and all this is to the power negative n, close bracket. Then divide by I, which is 11.2 over m times 100, which is 12 times 100. So to simplify this, we can simply divide both sides by 20,000 and you get 1.6 million over 20,000 multiply by 11.2 multiply by 11.2 over 1,200 it's equals to 1 minus 1. Let's just simplify it even further. 11.2 divided by 1,200 plus 1. 1 into 1.0093 to the power negative n. Let's see what the left hand side gives us. Point 747. What's the best way? We might as well take this one here, that side, and you are left with 1.00933 power minus n. You get negative 2. Sorry, there's a negative sign here. Negative 2.533 is equals to negative 1.00933 to the power minus n. Now, already you can take this off. And then after taking this off, you can introduce the log. Then you're going to have log of 0.2533 is equals to minus n, the log of 1,00933. After that, you can say negative n is equals to log 0.2533 divided by the log of 0.00933. In this case, log of 0.2533 divided by log of 1,00933. It gives you minus 147,864. Therefore, of course, they say calculate the months. You can just take this full number and say the number of months will be close to 147 months. So what does this mean? It means this guy will make 147 withdrawal until his 1.6 million is finished. Let's see. What does this mean? It means the total amount of money that he's going to withdraw is going to be 147 multiplied by 20,000, which is equals to, let's check, 2.94 million. So by just taking 1.6 million and investing in a fixed account, the total money that he's going to withdraw, if he withdraw 20,000 every month, is going to be 2.94 million. Of course, this shows how powerful is compound interest, how sustaining it can be, because this is really close to double the money that he invested. But not forgetting that the money loses value as time goes on. 147, very interesting. We'll have to look at this fact. 147 months is also equivalent to 12 years, 12.25 years, which says for 12 and 25 years, this guy will just be having a withdrawal of 20,000 every month from the 1.6 million that he initially invested, and at 11.2 interest rate. This is actually very good. I think I must consider putting 1.6 million into my bank account, and every month I get 20,000 rand. And for 12 years, I'll be a very happy man. Thank you very much. I hope you can practice. Of course, it gets very tricky when it involves logarithm. Also, one must be very strict in terms of the rounding off. Try to round off as far as possible when the logarithm gets involved, because it has a huge impact on your final answer. So thank you very much. I hope you really enjoyed. Again, this was the question in the previous exam. Please follow the step, try making mistakes, try doing it over and over again, so that by the time you are writing your final exam, you can be ready, you can be good to go, and you can get full marks when you get such question. Thank you very much. Let's see each other. Please don't forget to subscribe to our channel. Keep on watching so that you can ace your matric and get a distinction in mathematics. Enjoy the rest of your evening. I hope you will kick it when you see it.